We are starting with slide number 23 from the chapter 18 PowerPoint slides, and we're going to go through the notes on all of the structures of the nephron. If you remember, the nephron is, each nephron is a filtering unit of the kidney. What you're looking at here, this is slide 22, what you're looking at here is a juxtamedullary nephron. It's a nephron where the nephron loop goes down deep into the medulla of the kidney. But anyway, this nephron, the very beginning structure where blood enters the nephron, because what the nephron is doing is filtering a certain amount of blood. And that what's filtered from the blood is called filtrate until it enters the collecting duct and the papillary duct, where it's now called urine. Okay, so this first structure called the renal corpuscle, the purple component is the Bowman's capsule or glomerular capsule. This is where the filtrate is going to collect. And then the blood vessels here are called the glomerulus or the glomerular capillaries. So let's look at the renal corpuscle, look at the notes about the renal corpuscle. This is where the blood supply first contacts the nephron. It is a spherical structure consisting of two parts. Excuse me. First, you have the part that is the component of the nephron itself is the cup-shaped glomerular capsule or Bowman's capsule. I will call it the glomerular capsule. And inside of that capsule is a network of capillaries known as the glomerulus. So you have a component, the renal corpuscle consists of the part that collects filtrate that's going to become urine, and that's called the glomerular capsule. And then you have the part that belongs to the circulation, which is a network of capillaries called the glomerulus. So two parts of the renal corpuscle, the capsule and the glomerulus. Blood flows into the glomerulus from the afferent arteriole and leaves by the efferent arteriole and heads toward the peritubular capillaries. The fluid and dissolved solutes that are forced out of the capillaries collect in the capsular space, and this process is called filtration, and what's collected in the glomerular capsule is called filtrate. Then we move on to the renal tubule portion of the nephron, and that consists of the PCT, the nephron loop or loop of Henle. I will call it the nephron loop because that's what your e-text, that's the term your e-text uses most often. But PCT, nephron loop, and DCT. These are the components of the renal tubule. And then at the end, when you reach the end of the DCT, we call that filtrate the tubular fluid. Once the tubular fluid empties into the collecting duct, that is the beginning of the collecting system. Collecting ducts drain into the papillary ducts, into the minor calyces, and at this point we call this fluid urine. Okay, functions of the nephron. At the renal corpuscle, the function is filtration. The renal corpuscle produces filtrate. It is a passive process that's basically powered by blood pressure. The filtrate includes valuable nutrients that we will actually want to take back into our blood at some point. But for the time, the filtrate is going to include valuable nutrients, ions, and water, some of which we want to release with our urine and some of which we want to recapture and make sure it gets back into our blood. There are many important solutes that need to be conserved in the body that leave the blood. So in the tubules, one of the most important processes is reabsorption. The tubules will reabsorb useful molecules and ions from the filtrate back into the blood. So greater than 90% of the water that was filtered out of the blood in the renal corpuscle is going to be reabsorbed back into the blood when it reaches the renal tubules. And then another process that happens in the tubules is secretion of any waste products missed by filtration. They will be secreted from the blood back into the urine. So reabsorption is referring to stuff that's in the urine going back into the blood, and secretion is the opposite direction. It is stuff that's in the blood that needs to be excreted with the urine, and it was missed by the filtration process. And this is just a blown up picture of the renal corpuscle. You can see here the afferent arteriole. You can see the glomerular capillaries, which are surrounded by lining from the nephron itself that form these filtration slits that allow a lot of material to be filtered out of the blood into this capsule called the Bowman's capsule. So the purple thing here is a cup-shaped glomerular or Bowman's capsule. So we'll call it the glomerular capsule from now on. And then the capillaries here that are lined by the visceral layer of, actually it would be the visceral peritoneum. But anyway, this visceral layer has these extensions called podocytes, and they form slits called filtration slits. So you can see this picture enlarged, and we'll come back to it when we get to topics where we need to be looking at that picture. The glomerulus are the are endothelial cells composing the glomerulus is the capillaries that are composed of endothelial cells, and those endothelial cells have pores. Endothelial cells, remember, are just they're basically epithelial tissue, simple squamous tissue actually. But these walls in these blood vessels in these capillaries have pores, and the pores are called fenestrations. Then we have the glomerular capsule, which collects the filtrate, and the cells in this layer are called podocytes. They have foot processes called pedicels that wrap around the capillaries, creating filtration slits. And so these are the openings that the blood is going to be filtered through, is the filtration slits in the glomerular capsule and the fenestrations in the glomerulus. So by definition, the filtration membrane consists of the pores of the endothelial cells of the glomerular capillaries, fibers of the basement membrane of both the glomerular capillaries and the membrane, the basement membrane that comes from the glomerular capsule, from that visceral layer that we talked about. So we have two basement membranes. It's basically two layers of very, very thin epithelial tissue. One layer comes from the blood vessels and the other layer comes from the nephron. So there's going to be two basement membranes. So there's the cells that form the lining of the capillaries, and then there's the cells that form the lining of the nephron itself. And so we have the lining of the glomerular capillaries, the two basement membranes that touch, the filtration slits between the podocyte processes, and all together the three structures are known as the filtration membrane. Let's look at it in this picture here. In picture B. Oh, I didn't mean to do that. Okay. Let me blow it up. Here we go. All right, so here's what you have is this purple layer here, these purple cells, and this purple layer is formed from the nephron, and then then you have the red, which is formed from the capillaries. So the capillaries are coming from your blood, your blood vessels, your glomerulus. So this is a glomerular capillary. It's the cell that forms the lining of the glomerular capillary, and it's got pores in it. Then you've got the basement membrane between the two layers of tissue. Basement membrane for the capillary endothelium and the basement membrane for the portion of the glomerular capsule. Then you have the cells that form the glomerular capsule, and so there's pores within the glomerulus, and there are fenestrations formed by the podocytes in the glomerular capsule itself. So this is your filtration membrane. Here's the blood inside here. Here you can see red blood cell. Red blood cell's not going to fit through those pores, so the blood cells don't get filtered out, but almost everything else gets filtered out through this filtration membrane into this cup-shaped space here. It's called the capsular space. This is where the filtrate collects, and that would be this space right in here, okay? So before we move on to the PCT and reabsorption, in fact, let's go back. I just want to go back and review. Okay. So here we're looking at, if you look over to the left, you see this is an image of the nephron, and we're just looking at the beginning portion called the renal corpuscle. It's composed of the glomerulus, which is the capillary portion that has the blood inside of it, and then the glomerular capsule, which collects the filtrate that is filtered out of the blood. Okay? So filtration happens here. Now, ask yourself what the blood is composed of. What the blood that's entering into the glomerulus from the afferent arteriole, this blood has red blood cells, white blood cells, platelets, large proteins, and then other small solutes and water. So what's filtered out is everything besides the blood cells, because they're too large. See how large this red blood cell is compared to the pores? So it's anything that can fit through those pores and be pushed into the space by the pressure of our blood pressure. So everything besides the red blood cells, white blood cells, platelets, and large proteins that are dissolved in the blood to make it thicker than the tissue fluid. Okay, all of those things are held back because they're too large, but everything that's small enough to fit through those pores, which includes greater than 90% of the water and almost everything dissolved in the plasma, is filtered out. So now we're getting to the PCT, where we have to recollect or reabsorb the important stuff that our body needs. So the majority of reabsorption occurs in the PCT. The cells lining the PCT reabsorb organic nutrients. Now, what are organic nutrients? That's going to be glucose, amino acids, possibly like fatty acids, but definitely glucose and amino acids from carbohydrates and proteins that we get in our diet. So those are reabsorbed because we need those. Our body needs those. Plasma proteins that are small. Now, large plasma proteins are not reabsorbed because they never were filtered out. But plasma proteins and ions from the tubular fluid that was filtered in the renal corpuscle is now reabsorbed back into the blood. The substances are moved from the tubule to the interstitial fluid or peritubular fluid and then into the blood. Water will then follow by osmosis. So that's going to reduce the volume of the tubular fluid. So reabsorption, that's what happens in the PCT. Then the nephron loop is designed to concentrate the urine. There are two portions. There's the descending limb and the ascending limb. fluid in the descending limb is permeable to water but not solutes. So water moves out, solutes stay in, and as the filtrate gets further and further to the bottom of the loop, it gets more and more concentrated. Then in the ascending limb, the epithelial tissue that forms the ascending limb of the nephron loop is not permeable to water. So sodium and chloride are transported out of the tubule, and as you go down, you're getting more and more concentrated because water is leaving the tubule. Now as you go up, water doesn't leave, but sodium and chloride do, so you get less and less concentrated as you go up the ascending limb. So the result is a very high solute concentration in the peritubular fluid of the renal medulla. Now, if you were taking Bio 168 and Bio 169, in Bio 169 you would have a chapter on the urinary system, and you would go into a lot of detail about how this process works. For this class, and just for the sake of time, because our summer is wrapping up, we can't spend the time on it that maybe we would like to, that I would like to, you probably wouldn't, but you really need to just remember for the nephron loop, the function of it is to concentrate the urine. To concentrate the urine. What does that mean? It means make it more concentrated and less dilute, less watery. So the purpose of the nephron loop is to concentrate the urine. And you also need to know two things. You need to know that the descending limb is permeable to water. So water is moving out in the descending limb. The solutes are staying in. So at the bottom of the loop, when you get, here's the descending limb. So when you get to the bottom, you end up with very, very, very concentrated filtrate. Okay, very concentrated filtrate because water's moving out, but the solutes are staying in. Then as you go up, water can't leave, but salt and chloride ions are pumped out. So the fluid is less concentrated the further up that you go. But the purpose in general of the nephron loop is to concentrate the urine. Okay, then you get to the DCT. This is the last segment of the renal tubule. It's located in the cortex of the kidney, whereas the tubule was in the medulla, at least if it's a juxtamedullary nephron. The DCT passes close to the afferent and efferent arterioles. And so there's three vital processes that occur in the DCT. One is active secretion of ions, acids, drugs, and toxins. Secretion means this is stuff that didn't get filtered out the first time. So it's from the blood into the tubular fluid. It ends up in the urine if it's secretion. Reabsorption means it ends up in the blood. There is some reabsorption of sodium back into the blood at the level of the DCT. And this is at the point where your nephrons, your kidneys are like designed to help maintain blood pressure, and they do that by adjusting blood volume. So if they want to reabsorb water, they're going to reabsorb sodium because water's going to follow salt. So if at the DCT the kidneys decide they need to conserve water because you're dehydrated, they're going to reabsorb sodium and then reabsorb water because the water is going to follow the sodium back into your blood. But if you are, having edema or swelling, or, you need to release water, then it's going to be the opposite. That's why it says selective reabsorption.